today we're talking about limits. So hopefully that Mean Girls clip helped you realize that limits are really cool. I had this moment in pre-cal when I was in high school when we first started talking about limits, and I was like, oh my gosh, just like in Mean Girls, and my teacher got mad at me because I was talking about Mean Girls in class, and I was like, I'm sorry, I'm just trying to connect this to my real life. So anyways, limits are really cool. It's kind of like an abstract concept at first, so it takes a little bit of time to get used to it. So what a limit is as you're approaching a certain x value, you're also simultaneously approaching a certain y value. So like as you're getting closer and closer and closer and closer to a point, you're getting closer and closer like to that x value, you're also getting closer and closer and closer to a y value, corresponding y value. So on this example, f of x equals x cubed minus 1 over x minus 1. If you factored this out, you would end up canceling out x minus 1, so you have a whole at 1. So when you graph this, it looks like this, and you have a whole at 1. So to kind of demonstrate what exactly is a limit, I created this t-chart by plugging in different values of x. And if you notice, we start at 0.75, then we go up to 0.9, then we get to 0.99, then we get to 0.99, sorry, that should say 999. And so we are getting closer and closer and closer to 1. So x is approaching 1. And we're approaching 1 from the left. So we're getting bigger. So as you move towards your bigger numbers on your number line, you're moving towards the left. Moving towards the right from the left. So we're coming from the left. Which on our graph, if you notice my cursor, that would be like coming at this hole from the left. So we're coming from the left. We're approaching 1 from the left. Over here, from the right, our numbers are getting smaller. 1.25, 1.1, 1.01, 1.001. So we're getting closer and closer and closer to 1. X is approaching 1. From the right. If you notice, as x approaches 1 from the left, our y values, 2.3, 2.7, 2.97, 2.997, these are getting bigger and bigger and bigger, and they are approaching 3. This is getting really, really close to 3. So f of x, or y, either way, is approaching 3. And as x is approaching 1 from the right, the y values are getting smaller and smaller and smaller. So 3.81, 3.3, 3.03, 3.003, they're getting smaller and smaller, but still getting closer and closer to 3. So y is also approaching. Y, or f of x, sorry, is approaching 3. So, you might be tempted on your number line to then go put 3 in your y value. However, we have a hole at 1. If you were going to like factor this out, the x minus 1, you have some other stuff, over x minus 1, those cancel out. So you have a hole at 1. So there's not actually a point there. So we can't put 1, 3 on our number line. There's not a point that exists at x equals 1. There's a hole there. But the limit is not saying that there's a point there. It's saying that as you get really, 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 really close to x equals 1, you're getting really, really, really close to y equals 3 from both sides. So as you get closer and closer and closer to x equals 1, you're getting closer and closer and closer to y equals 3 from both directions. So even though there's not actually a point there, the limit exists. as you approach it, you're getting closer and closer and closer to that number. You're not actually going to hit it because there's a hole there, but you're getting closer and closer. So the way that we would write this in limit notation would be the limit as x approaches 1 of f of x, so of our function. The limit of f of x as x approaches 1 is 3. So as x gets closer and closer and closer to 1, f of x is getting closer and closer and closer to 3. This is not saying that 1, 3 is one of our points on our graph. It's just saying that as you get really, really close to x equals 1, your y value is getting really, really close to 3. Alright, our next example is f of x is equal to the absolute value of x over x. And I'm asking you what is the limit as x approaches 0 of f of x. So first we want to graph this. Let's start with plugging in positive numbers. So if you plugged in 1, the absolute value of 1 is 1 over 1, which is 1. 2, absolute value of 2 is 2 over 2, which is 1. 3, the absolute value of 3 is 3 over 3 equals 1. So what I'm noticing here is I would point at 1, 1, 2, 1, 3, 1. It's going to keep going for forever. And I'm going to keep going this way, but at 0, I'm going to have a hole because I can't have 0 in my denominator. So this is an open circle at 0. Then let's plug in negative numbers, like negative 1. The absolute value of negative 1 over negative 1. The absolute value of negative 1 is 1 over negative 1 is negative 1. Negative 2. Absolute value of negative 2 over negative 2. Well, the absolute value of negative 2 is positive 2. So positive 2 over negative 2 is negative 1. So same situation, similar situation. Negative 1, negative 1. Negative 2, negative 1. Negative 3, negative 1. And you can keep going until you get to 0 because, again, you can't have 0 in your denominator. So these are both open circles. So, as x approaches 0 from the left, so as we get closer and closer and closer to 0, coming at it from the left, y approaches negative 1. Our y value is negative 1. So as x gets closer and closer and closer to 0, my y value that I'm approaching is negative 1. Well, over here, as x approaches 0 from the right, so as I'm coming at it this way, as I'm approaching 0 from the right, y is approaching positive 1. So from the left, y is approaching negative 1. From the right, y is approaching positive 1. So when the limit from the left is not equal to the limit from the right, here's your big idea. When the limit from the left does not equal the limit from the right, the overall limit does not exist. And feel free to abbreviate does not exist as D and E. So just like Lindsay Lohan and Mean Girls, limits that exist in this situation. So we can write this in limit notation. The limit from the left, the limit as x approaches 0, the way you designate that you're approaching it from the left is you put a little negative sign, kind of like an exponent. Looks really ugly the more I scribble it. The limit as x approaches 0, this little negative designates that it's from the left of f of x is equal to -1. The limit as x approaches 0 from the right, I'm going to put a little positive sign for the right. So the limit as x approaches 0 from the right is equal to +1. So your limit from your left exists, the limit from the right exists, but since they're not the same number, the overall limit, the limit as x approaches 0, I'm not designating it from the left or from the right, it's the overall limit. The limit of f of x as x approaches 0 does not exist. So the way that you designate that you're looking at the limit from the left is you use a little negative sign. The way that you designate you're talking about the limit from the right is you use a little positive sign.